Assalamu alaikum warahmatullahi wabarakatuh. Welcome dear students, second prep, unit 3. Remember, the simple space. The simple space is the set of all possible outcomes of random experiments and it's denoted by S. The number of its element is denoted by N of S, or number of elements of simple space. For example, as dosing a pair coin once, then the simple space equal head or tail. As flipping a pair die once and observing the apparent number on the upper face, then S equal 1, 2, 3, 4, 5, 6. The event, it is a subset of the simplest space. For example, if A is an event of appearance of an odd number when we throw a pair dice once and observe the appearance number on the upper face, then A equal 1, 3, 5 because it's the odd numbers in dice and A subset from the simple space, and it says that A is an event in S. Generally, the probability of occurrence of an event A subset from S is denoted by probability of A. It is found by using the relation probability of A equal the number of elements of A over the number of elements of the simple space. Remark, number 1, the probability of impossible event is equal 0 and probability of certain or sure event equal 1. Number 3, probability of any event is not less than 0 and is not more than 1. Then probability of A must be bigger than or equal 0 or smaller than or equal 1, and probability of A belong to the interval 0 closed and 1 closed. Example number 1, complete the following. The probability of impossible event equal 0 and probability of certain event equal 1. For every event A, we find that probability of A must be belong to interval closed from 0 to and 1 closed. C. If a pair coin is tossed once, then probability of appearance of head, only we have one head over the total number of coin is 2, head or tail, then the probability equal 1 over 2. 10 cards numbered from 1 to 10, a card is drawn randomly, then probability that the card carry a prime number. The prime numbers between 1 and 10 we have 2, 3, 5, 7. We have 4 prime numbers between 1 and 10. Then probability of the prime number between 1 and 10 equal 4 over 10, and in simplest form equal 2 over 5 or 0.4. E. A box contains 5 white balls, 7 red, and 3 blue. If ball is drawn from the box randomly, then probability that the drawn ball is blue. We have 3 blue, and the sum of all balls 3 plus 7 equal 10 plus 5 equal 15. Then probability equal 3 over 15, in simplest form equal 1 over 5. F. A bag contains 12 balls, 4 of them are red, 6 are green, and the rest are blue. If one ball is chosen random, then probability of getting blue ball. First, we must find the number of blue ball. All balls equal 12, total equal 12, minus 4 red and 6 green will equal 2. Then probability of blue will equal 2 over the total, which equal 12, in simplest form equal 1 over 6. In the experiment of throwing a pair die and observing the number of upper face, then probability of getting a number greater than 4. The number greater than 4 in die is number 5 and number 6. We have only two numbers over 6, and in simplest form will equal 1 over 3. An experiment of throwing a pair die and observing the number on the upper face, then probability of getting a number less than 1. Of course, we don't have any numbers smaller than 1 in the pair dice. Then the probability will equal 0/6, which equal 0. It's impossible even. A box contains 48 oranges. 4 of them are bad. If we draw an orange at random, then probability that the drawn orange is bad, we have 4 bad over the total, which equal 48, and simplest form will equal 1/12. And the probability that is not bad, all oranges, is 48. 4 of them are bad, then the not bad will equal 48 minus 4, which equal 44, over the total equal 48, equal in simplest form 11/12. J, if the probability of occurrence an event is 5/8, then probability of non-occurrence of this event, we know that the sum of all probabilities must be equal 1. If the occurrence of this event 5/8, then probability of non-occurrence will equal 1 minus 5/8, which equal 3/8. The simplest form here, 3/8. Exam number 2. Exam number 2. A numbered card is selected random from the set of similar cards numbered from 1 to 24. Find the probability of getting a card that carry. First, multiple of 4. We have numbered from 1 to 24, 1, 2, 3, 4, 5, and so on. Multiple of 4, which is the table 4. 4 times 1 will equal 4. 4 multiplied by 2 will equal 8. 4 multiplied by 3 will equal 12. 4 multiplied by 4 equals 16. 4 multiplied by 5 equals 20. 4 multiplied by 6 equals 24. Then we have 1, 2, 3, 4, 5, 6 number. Then probability of multiple of 4 equals 6/24, which equal 1/4. B, multiple of 6. We have 6 times 1 equals 6. 6 times 2 will equal 12. 6 times 3 will equal 18. 6 times 4 will equal 24. Then we have 4 numbers. Then probability equal 4/24, which equal 1/6. Multiple of 4 and 6 together, we need number which in multiple of 4 and also multiple of 6. We have 12 and 24, only 2 numbers. Then probability will equal 2/24, which equal 1/12. D, multiple of 4 or 6, any of these 2 numbers without repeating the numbers. Then we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 numbers, then probability will equal 8/24, which equal 1/3. A number divisible by 25. The greatest number here is 24, and of course, none of the following numbers is divisible by 25. Then probability will equal 0/24, which equal 0. If a positive integer less than 25, we need number is positive and is smaller than 25. Of course, all these numbers are positive numbers and also is smaller than 25. Then will equal 24/24, which equal 1. Thanks for watching and goodbye.